Hello and welcome to another Zozin session. How about that? How about that? Welcome. So today we're gonna continue yet again working on a Wang tile grid generator. All right. And the idea of today's stream is going to be extremely freaking simple. Let me adjust my window so it doesn't look weird. Just a second. So we already have a thing that is capable of rendering this stuff. And it can render all sorts of different tiles and whatnot. For more explanation on how we render the tiles and what are the tiles, I recommend you to check out this playlist, where we have all of the archived recordings of the screencasts of me developing this entire thing. You can find it in the chat if you're watching it on Twitch, or you can find it in the description if you're watching it on YouTube. And of course, in the description, you will be able to find the source code of this entire thing, of course. All right, the idea of this thing is super simple. We are generating all of that into PNG files, right? So let's take a look at what we have in here. We have some profiling from the previous stream, so let's actually check out the master, right? So let's check out the master and let's fetch the latest stuff, right? Let's fetch the latest stuff and git merge origin master. So, and let's delete nest profiler. I supposed to say nested profiler, but I mean nest profiler doesn't really sound that bad. Actually, it sounds like a thing that you may have, right? So let's actually rebuild everything. And after that, I'm going to run that thing, and it will generate us basically a tile grid. 30 by 17 tiles, and each tile is 64 by 64 pixels, right? So we can take a look at the atlas that got generated. So here is the atlas. So it's basically the black and white version, but with red and cyan for some reason. So I don't know why, probably because of the settings. And the final grid looks like this. So the encoding is probably shit right now, so let me actually do something about that. So let's actually find the colors. So this one we need to comment it out. So then I think black and white is around here somewhere, right? So let's rebuild everything, right? So in that case, it's going to be black and white. And then we're going to say that the background is going to be black. And let's take a look at the final grid in here. There you go. Yeah, so the background is fine. So, okay, we have a thing that generates this kind of tile grids into a PNG files, right? So this thing just generates PNG files, nothing special. What we want to do now, we want to hook up that renderer into X11 window. Right. So, and the reason why I'm going to use X11 window is because the renderer itself is completely CPU. It's a completely software renderer. It uses multi-threading to actually split some work and speed things up. But apart from that, it's not really hardware accelerated in any particular special way, like using GPUs or anything like that. And I kind of want to keep it that way. I kind of want to like even render it using as primitive technologies as possible, and for that I think rendering using X11 would be perfect, and specifically X11 without any special extensions like GLX or double buffering. I think the X11 has a special extension specifically for the double buffering. We're going to try to organize our own double buffering ourselves. I think this is done by allocating additional pix map and using it as a back buffer. We'll see how it goes. So, and yeah, I want to write a very simple X11 application, as simple as possible, and just take the frame buffer that we generate, the buffer of pixels that we generate during the rendering, and just display that in a window. Once we'll be able to display that in a window, we want to try to animate that tile grid in 60 FPS. And I think it is doable, right? If you run this thing like several times, you will see that rendering takes about like 3 milliseconds up to usually 10 milliseconds. And to render at 60 FPS, you need 16 milliseconds. So the rendering of the whole thing in full HD, by the way, in full HD, takes less than a single frame in 60 FPS. So So according to our calculations, it should be doable to animate this kind of thing in 60 FPS. So the things we're going to animate, I think like for this specific tile grid, I want to animate the radius of blobs, right? I want them to shrink and expand, maybe in sine motion somehow, just to see how it will go. And yeah, all of that is going to be done, at least I plan to, without using OpenGL or any GPU acceleration, if that makes any sense. So that's the plan for today's stream. Does it sound good? Sounds Gucci? Sounds Tamaguchi? Let's go. Uvu. All right. So let me see. So I haven't written X11 applications in quite some time, so I may forget some things, and I'm going to be extremely frustrating because X11 and specifically Xlib is a huge pile of crap. So expect me to be frustrated a lot. So that's the usual thing that that goes when I try to do X11. Esther, what's up? As someone working on graphics API the last full year or so, this sounds like a good go, right? Yeah. The cool thing about this entire stuff is that it's simple, right? So you just write into a back buffer and it just yeah, it just works. You don't have to mess with a lot of weird APIs and stuff like that. So all right, let me see. So the first thing we need to do, I want to have an Xlib manual. Right, so there is an official Xlib manual, which is in PDF. You can find it in here. So you can always find them by just googling Xlib manual. This is the official Xlib manual, and it contains everything that you probably need. Something like XOpenDisplay, right? So, and then here is the function that you need to call at the beginning of your X11, adventures. It has the descriptions of all of the arguments and stuff like that. We can download this thing, in here. It's going to be wget. So let's go. I'm also going to put this thing in the description, the official Xlib manual, right? So there we go. But there is another version that is at the top of the Google search, right? And it's at the top of the Google search for a reason, because I believe majority of people use that thing instead of the official one. So this is a conversion of the official Xlib programming manual into HTML. Right, so you can use this website, but I kind of prefer to actually download the whole website. So there is an option to download this whole website as a tarball, which is extremely convenient, right? So, and the entire website, just a bunch of HTML pages, is going to be locally on your machine. So let's actually unpack the entire thing, right? And the cool thing in here is that you can grab it. So quite easily, XOpenDisplay, right? And you can find all of the mentioning of this specific thing. I think it's supposed to do it like that, right? If I use CM. And yeah, it's a little bit more convenient than the search capabilities of the PDF readers. It actually depends on the PDF readers, but it's better than search capabilities of my PDF readers. Maybe your PDF reader is better. But another interesting thing here is that there is a function index in here, which allows you to just open it in the browser and find the function and just quickly jump in there, which is quite convenient. So, and all of that is locally. You don't need any internet connection or anything like that. Imagine not having internet connection in 2021. My God. Anyway, so let's actually give this, I'm gonna give the link to this website in here. So the official Xlib, the HTML conversion of the official Xlib manual, right? So there we go. So we're going to be using this thing. And now, did I start Emacs from within my development environment? Let's actually find out. There we go. So the first thing I'm gonna do, I'm gonna actually go to, yeah, I even have a to-do for that. As you can see, live rendering with Xlib. In fact, I have a lot of to-dos in this project specifically, right? And I feel like I'm not gonna be able to address all of them. There's a lot of things that are pretty much not that important, and I'm gonna wrap up this project pretty soon. I think I'm gonna wrap it up as soon as I'm done with live rendering, if you know what I'm talking about, right? So I just want to see if it's possible to render it on CPU without OpenGL or anything like that at 60 FPS. And if it is, I'm just gonna make a mental note in my head and just move on with my life, doing other experimentations and other things, right? So, but there's still a lot of things that would be cool to do, but I'm not sure if I'm gonna do that eventually. So the most important thing right now here is just a live rendering. So. But I still like to put to-dos just in case, just to like make a note that it would be nice to have that thing in here, but we don't really have enough resources to do that. So, oh well, it is what it is, and it isn't what it isn't. What tool you use for getting to do? Well, my brain forgets them automatically. It's called Snitch, right? So you can find the source code of this tool in here. It's written in Go, and for people who's watching on YouTube, I'm gonna also leave this in here. CPU rendering is a super fun idea. I've never tried it. It's actually super fun, right? You just like write pixel by pixel into an array. So in our case, it's actually super dumb. So we have a global array of pixels, and we have a bunch of threads that actually write into their allocated tiles within that array that do not intersect, so no synchronization is necessary, right? And then after we basically waited until all of the threads have finished their work, we just take that buffer of pixels and we just dump it into the PNG file. So that's how it works. There's no mutexes, there is no like atomic variables or anything like that. We just take the entire thing, split it, you know, independently between several threads, just let the threads do the work, and then just dump it to PNG. I want to do the same, but live updating, right? So I want to organize the rendering loop that is going to call this process over and over again on each frame, and then that resulting frame is going to be just displayed with the X11. So that's the idea. It is as simple as it can get. So the actual splitting of the work is not really smart, right? But it's something. It actually sped up the entire rendering like twice. Anyway, so what was doing? Oh yeah, Snitch. Yeah. So you can read more about this thing in the README. So basically, it's a tool for managing your to-dos in the source code, and the primary purpose of that tool is to actually collect all of the to-dos in your repo and report them as issues in the issue tracker of that repo. Right, so, but you can also use it to just find all the to-dos in your project, as you do here, right? So I just find all of the to-dos in the repo, and then I can just jump them and just look at them and stuff like that. You can actually totally use something like grep for this thing. So you can do git grep rn to do, and there you go. Here are all of the repos that you want to do. So this is just a grep. Right, so using Snitch for this kind of stuff would be an overkill, but I don't know, whatever, doesn't really matter. And I'm gonna leave this thing in the description for people who's watching on YouTube. Of course, Snitch the to-do manager, right? So let me see what we've got. Let me see what we've got. What I want it to do. I think I want it to. Yeah, I want you to start actually working on this thing. So the first thing I'm going to do, I'm going to rename this entry point to something else, which will make it not an entry point. And I'm going to create a parallel experimental entry point where I'm going to experiment with X11 ideas. Right, so in any X11 application, the first call that you need to perform is the call to XOpenDisplay. So that's the first thing you need to do. Right, you need to open the display, and here you're going to have a display. Right, and you have to provide the name of the display, and the name of the display is the C string. Right, and as far as I know, you can actually leave it as null. So it specifies the hardware display name, which determines the display and communication domain to be used. On the POSIX conformant system, if the display name is null, it defaults to the value of the display environment variable. Do we even have anything? So echo display, it is a 0. Okay, so we're gonna use the default display, right? Whatever is set in the environment variable. Right, so, and let's try to compile that. So after you're done, I think you have to close display. Right, so basically by opening display, you open the connection to the X server, and by closing the display, you close the connection, and that's pretty much it. So, so it accepts the display, it closes the connection to the X server for the display, specifies blah, 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 and destroys all of the window resources IDs, Windows, font, PixMax, color maps, and so on and so forth. So you don't have to worry about that, right? So you just close the display and it will destroy all of the resources automatically, just like, you know, with the operating system. Operating system automatically closes all of your files, unmaps all of the pages, right? You don't have to worry about it too much, unless if you have a connection with some sort of remote server that expects you to send something when you terminate. But the question is, why protocol requires you to do this kind of stuff or something? I don't know. Anyway, so yeah, it is better to manage resources in bulk, right? So people quite often like to manage each individual small objects by themselves, right? But it's way more efficient and way more convenient to realize that a lot of these objects, they actually have pretty much the same lifetime, right? And once you realize that a lot of whole groups of objects have the same lifetime, you can manage them simultaneously. You can allocate them simultaneously and you can deallocate them simultaneously. Like in case of an operating system and a file and memory, and like in case of the X servers, windows, resources, color maps, cursors and stuff like that. All of this stuff usually lives for the entirety of the whole application, so it can be allocated at once and deallocated at once, making it very convenient and very efficient. So yeah. All right, so anyway, so we open the display and we close the display. So I'm gonna say that I'm not gonna accept any arguments, and let's try to compile the entire thing and see how miserably this entire thing will fail. And it will fail quite miserably because it doesn't know anything about the display. So we'll probably have to include I think it's X11 Xlib.h. I think that's what it is, X11 Xlib.h, and it is compiling, but I think it's not going to link. It actually takes too much time to process. All right, why did it take so much time? So, I mean, it didn't link properly because it doesn't know anything about XOpenDisplay, but why did it take so much time? Is that because of the header? Is processing the X11 header takes so much time? Or what's going on? It's actually very interesting. Why did it take so much time? So if I go back and just remove that, we can also measure the time. No, I think it's not that. I think it's primarily STB. I think it's primarily STB. Yeah, so it's around 4 seconds. Okay. So let me see. So let's actually uncomment the entire thing. So it probably was always like that. Okay, so now if we go to this entire thing, right, so as you remember, it actually failed because of the linking, so we need to link it with X11, I think. And let's try to rebuild the entire thing, and yeah, we have 2 mains. So this one is going to be 2, and there we go. Alright, so it actually 8 seconds. Alright, if I try to run the entire thing, it will do nothing, right? So it just probably opened the connection and closed the connection. So we can try to maybe take a look in the debugger and see if it actually opened the connection, right? So let me see, it has to be something like Wang, I suppose. There we go, and I want to break on main. Okay, that's really strange. Where is the Wang executive? Oh, okay, I was in the wrong directory. Okay, so I suppose for it to properly work, I have to do something like this. right? And then we're gonna break on main. Then we're gonna run the entire thing. Just a second. Right, so there we go. So, and if we step, right, and if we take a look at the display, we've got the display. Right, we've got an actual display, and we can even take a look inside of the display. It's incomplete type. We're not even allowed to look inside of the display because it's an opaque structure, right? So, and by the way, in case of an error, the display actually returns null, right? So you have to do display null, and if it is, you have to fail with an error saying couldn't open the display connection. Willington WA, thank you so much for 3 months of Twitch Prime subscription. Thank you, thank you, thank you, and welcome to Epic X11 Club. How about that? Cheers. Interesting. I think like X11 headers actually slow down the compilation. Well, I mean, there is a reason people created such thing as XCB, right? So there is a reason people actually like spend their time doing something like this. Right, because the whole point of XCB, as far as I know, is to be a replacement for Xlib, which is smaller and faster. So maybe at some point we're gonna look at the XCB, but I know nothing about XCB. I know nothing about Xlib either, right? But I know less about XCB than I know about Xlib. So I don't really want to jump too much into unknown territory. And on top of that, it has a CVE assigned to it. So let's take a look at what kind of vulnerabilities do we have in this thing. Does your Xlib have such epic vulnerabilities? Or maybe it's not actually vulnerability of XCB. Fixing the Python code to work with Python 3 and fixing the integer overflow in the read packet function. Okay, so it does have an integer overflow vulnerability. Can your Xlib do that? I don't think so. Anyway, pretty epic. Pretty epic. Okay, so let's do std error, and error could not open the default display, and we are going to exit with 1. There we go. So after we open the display, the next thing we have to create is the window, actually. So you open the connection to the X server, and you need to ask X server, Mr. X server, please create the window. So let's try to do that. So there's a couple of functions to create a window. As far as I know, in X11, Xlib specifically, you can just create a window. But this is a very scary function, because look at it. It accepts crap ton of parameters. You need a display, you need a parent. Well, position and border is fine, you need to know the class or whatever. And the most important thing, you have to provide something called visual. And visual, by the way, is a very important concept apparently in Xlib or X11 in general. So visual is basically a description of so I didn't even know a description of what, of colors or something. So on some display hardware, it may be possible to deal with color resources in more than one way. For example, you may be able to deal with a screen for either 12-bit depth with arbitrary mapping of pixels to color, pseudocolor, and 24-bit depth with 8-bit blah blah blah. These different ways of dealing with the visual aspects of the screen are called visuals. Right. So visual is a way of dealing with the visual aspects of the screen. And apparently visual is like a central type in X11, because a lot of functions, a lot of things that allocate X11 resources, they are dependent on the way of dealing with the visual aspects of the screen. Whatever is that supposed to mean? I suppose it's a depth, it's like color representations and stuff like that. So yeah, so there is a whole structure, I think, that describes this entire thing. So visual type. Determining the appropriate visual type. There we go. So the visual, it's actually XVisual info, right? So it's a specific screen, depth, class, the mask that you use to extract red, green, blue, stuff like that, bits per color, and stuff like that. So yes, but it's also XVisual in 4. It's not particularly XVisual. But anyway, so you have to know the visual. You need to know the way of dealing with the visual aspect of the screen, and some sort of a value mask, some sort of attributes. There is also a lot of window attribute And wait a second, did it actually redirect me to some? Okay, so we have a missing pages in here, apparently, in this HTML conversion. So I suppose maybe it should redirect in here. Oh, here it is. So it's a visual attribute. I suppose it's supposed to redirect to the index. Right, so it's a scary thing. So because of that, there is a simpler version called CreateSimpleWindow. Right. So because this is not a simple way of creating a window, and this is a simple way of creating a window. Here you just need to provide the display, the parent window, the position width, the border, and the background, and that's it. And it will pick the rest of these things for you automatically. It will just pick the defaults. So it kind of reminds me, this is like a recurring theme in all of these old libraries. Like, right, in Xlib you have a difficult way of doing things, and you have an easy way of doing things. And if there is an easy way to do things, we have to explicitly say that this is the easy way of doing things, right? And it's something like simple in curl, because in curl there is also easy API, because the original curl API was actually overcomplicated, so they had to create the easy interface. So it's easier to use that. Right, so it's like a recurring theme in all of these libraries, right? So they're so over-engineered, so over-complicated that they actually have to sit down. Okay, we need a simpler way to do this shit. Let's create the easy API, right? And everyone is, whoa, the easy version, finally, finally. Oh boy. So. And yeah, that's probably what we're gonna use right now. So because I don't want to deal with like how do I even get the current visual. Maybe there is a way to know the default visual. You can copy from parent, apparently. Yeah, you can copy it from parent. So anyway, let's just grab this entire thing and deal with it already. So here's the window, right? So and that's it basically. So what's going to be the parent? I think you set the parent as the root of the display, if I remember correctly. So I think it's something like a root, a default root window. Yeah. Default root window. It's an X default root window. Specifies the connect. Yeah, both return the root window for the default screen. Yeah, so you can use this as the parent for your window, right? So this is gonna be, there we go. So where are we gonna place it? I didn't think it matters where we're gonna place all of that, right? So we're gonna put it like at 0, 0. What's gonna be width and height? I don't know, it doesn't really matter. So it's gonna be 800 by 600, there we go. So border width is probably going to be 0. I don't really need any border. So in the border itself, create window, right? So let's create a window. Specifies the border pixel value of the window. I don't remember. Can you just supply like black there or something? I think if I put 0 in here, it's going to be black, and if I put 0 in here, the background is also going to be black. So there you go. We created the window. Basically created the window. Let's try to compile the entire thing, right? Probably we have to, yeah, probably have to go in here. Right, so it's gonna be no build. So let me try the rest of the things. So this is gonna be GDP and Wang. So let's break on main. I don't know, I probably did a wrong thing yet again. The thing about the debugger is that if it cannot find the file, it still succeeds for some reason. It's really, really annoying. Right, so here's the full name. And if I try to break on main, okay, so finally it works. If I try to run the entire thing, there we go. So we have a display. All right, then we create the window. And now if we take a look at the window, right, so it got optimized out, right? How can we make it not be optimized out? It's kind of strange that it optimizes out like the whole call to the function, right? So what if this function does a side effect? So, I mean, it probably optimized out only the location on the stack. It didn't really optimize out the call, right? So I don't think it optimized out the call. So it probably performed the side effect, but it just threw away the entire thing. All right. So, but I still want you to take a look at the window itself. So maybe we're gonna go ahead and disable all of the optimizations just for now, just to hope that it's not gonna do the thing, right? And it actually compiled way faster, I think. Right. So maybe I should start. Yeah, I should start actually compiling things in an optimized ways to compile them faster. Right. So now. In here, I can do GDB, right, like this, and we're gonna break on main. We're gonna run the entire thing, boom, boom. So we have a display. Then the next one, we have a window, right? So here's the window, and it's just a number. That's an interesting. So it's basically an ID. Okay, that looks fine. Cool. So the next thing we need to do, so the window, as you can see, we created the window, but we cannot see the window. The thing we need to do, we actually need to display the window. And you know how displaying the window in X11 called in terms of the X11? Do you guys know the terminology of X11? The making the windows visible is called mapping it, because of course that's how you call an operation of making the window visible. It is called mapping the window. Obviously, it's a very, very intuitive name. So, and the function that does that is called Xmap window, right? So, and of course, it has like a long, elaborate explanation of what it exactly does. So, function maps the window and all of its sub-windows that have a head map request. Map a window that has an unmapped ancestor does not display the window, but marks it as eligible for display when the ancestor becomes mapped. Such a window is called unviewable when all of the okay, whatever. So we just want to display the window, okay? So let's actually put this thing in here. Right, so we provide the display, we provide the window, and if I try to run this entire thing now, it is gonna quit super quick. I think it's not gonna be even visible that it created the window or something, so we'll probably have to sleep for like 1 second, maybe even 4 seconds to actually see the window, right? So, and we still can't see the window, which is actually kind of interesting. Maybe we have to like wait. So yeah, maybe we have to wait until it's done. So maybe there should be some sort of a synchronization of our nation. So because one of the things about X11 is that it's asynchronous, right? It is asynchronous, and because it works over the network, so each individual sort of call, it does not appear like immediately, right? So you can actually have several calls, and then at some point you can do like xsync or xflash or something like that. So xsync function flashes all the output buffers and then wait until all requests have been received and processed by the X server. Any errors generated, blah 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 blah. So yeah, you want to do something like this. I wonder if we want to actually do xsync display, right? And discard basically indicates that it will discard all of the events in the event queue for whatever reason. I don't know why it has anything to do with the event queue. Right, but you can do that, right? You can actually do that. All right, so let's actually do that. I think I'm gonna put a false in here, right? So it's a boolean, that means I can just put a false. I think in terms of the X11 is just the X false, right? And there we go, we have a window, look at that! We just have to synchronize everything, yes. And you know, the question is, how are you supposed to know that? And the question is, you're not, because this API is shit. Anyway, so this is just something that you have to know, right? Right, so because all of these things are asynchronous, right? So that means before the sleep, some of those things may not actually finish. So that's why you have to sort of synchronize. And if you don't synchronize it, right, so you won't be able to see any window, right? You won't be able to see any window. But if you synchronize it, right, until you basically wait until all of the requests has finished before sleeping, right, so that will kind of work. There we go. I wonder if just a second. So this is the background, right? This is the background. What if I put like a random values in here, like something 255? Will the color change because of that? Yeah, apparently. Okay, so that's pretty cool. We can already have different colors. Look at that. Chat. 1, 2, 3, 4. 4 calls, and you can already display blue color. Can your Win API do that? Can you display a blue screen in you know, in 4 colors of Win API? So I don't think so. Anyway, so 255 is essentially FF, so that means the blue is somewhere at the end, so that means it's RGB essentially, so 0, 0, 0, 0, 0, 0, right? And if I understand correctly, to display red, I'm going off of the pure intuition right now. I know nothing about how the colors are represented in here, right? So this is my pure intuition. So I suppose by doing that, it will be red, right? So we can give it a try. It is red. Would you look at that? This is amazing. The color of the communism. And here I suppose we have alpha, so this is R, G, and B, right? So, and we can do the yellow one, right? So yeah, we can have different backgrounds. That's actually amazing. Holy fucking shit, that's fucking amazing. So, and these are the borders, right? So we set the border, create a window. We wanted to create a simple window, right? So the first thing, the border width. Okay, so what if I set the border width to 69, right? And then I suppose the border, it has the type long, the same type as background, right? That means if I put something like this, so let's actually make it red. So it's going to have the red color border, if I understand. There, okay, so that's the thing you can do in Excel. I didn't know that, by the way. Right, so the only thing I knew is that like you need to open the display, you need to create a window, and that the way of showing the window is mapping the window. I didn't know how these parameters work, but apparently they're pretty, you know, self-explanatory. So yeah, that's pretty pow, isn't it? Isn't it, chat? I think it is. So alrighty, so we're gonna actually go with just black everywhere, so because we don't really need any of this stuff. Alright, seems cool. So I suppose we also need to organize the event loop, right, somehow for this thing. And the way you organize the event loop, if I remember correctly, you use a function x next event, right? So, and this is a pretty straightforward function. It basically accepts the display, your connection, and pointer to an event structure, right? An event could be of any sort of type, right? So, right, you can have like key presses, mouse buttons, and so on and so forth. You can even have like a create window event, and all of that controlled by the type of the event. And I don't know if there is any list of all of the possible types for the event. By the way, this is actually very similar to SDL. I think SDL basically copied this entire structure. If you take a look at this, the SdlEvent definition, right? Right. it is kind of similar. It's just like a union of these things. Well, there is no exact definition of the union structure, so but we can find it in user include SDL2 something event, right? And so this is the enumeration, and the actual thing should be somewhere here. Union. There we go. So it is kind of similar to X11. I think that's the most intuitive way of organizing basically different kinds of events that can happen, so that's why they look similar, right? You know what I'm talking about? So, but it's kind of interesting to see these parallels, right? So I think in WinAPI, this kind of event is called message. I think in the terminology of WinAPI, they are messages, right? So it's msg. Right, and I wonder if msg is also organized in a similar way. Yeah, it's the tagged union. Basically a tagged union. Because here is the union and here is the tag, right? So yeah. What do we have? So this is the tag message, and so it's slightly different. So message, I suppose, is the type, and then I don't even know where we have parameters. So there's a point or something. I know nothing about WinAPI actually, so I'm not gonna even pretend that I understand how it works, because I don't even have money to buy Windows, okay? So that's the only reason why I use Linux. I'm too poor for operating systems like Windows and Mac OS, so I have to use pleb Linux operating system because it's free, right? So it is what it is, and it isn't what it isn't. A hard life of Russian, right? So in Russia we don't have any money, so that's why we all use Windows. I mean Linux. So we definitely do not pirate Windows. So okay, so let's actually organize the loop. So we have to call to next event, right? So it also returns something as far as I know. So function copy is the first. If the event is empty, flushes the output. I don't remember if it returns anything. That's the problem. I don't remember if it returns anything because it doesn't show the return value in here, and I'm not sure if it's safe to assume that it doesn't return anything. Look, CreateSimpleWindow. Okay, so they do return something. That means probably we can just assume that it's void. Right, so let's do something like quit, and quit is gonna be 0 initially. So while not quit, we're gonna be doing X next event. We provide the display, and we probably also need to allocate the event structure in here, and then provide the pointer to the event. And this is where we're going to be discriminating on different types of the event. But unfortunately, in the documentation, it's kind of difficult to find where are all of these types, right? X next event, right? So here's the X next event. So returning the next event, okay, you can also pick the event, right, which does not really return the thing from the stuff. So the only thing I care about is where can I get the list of all of the events, like event types, right? Because this is not an enumeration. So there must be a way to know that. So let me go to the Xlib, and maybe there are event. Okay, so there's events, right? And here is the types. And maybe if we open the types like this, we'll find, okay, so here is, okay, so here it is. I think this is the event type. Okay, that's what I was looking for. Different like key press, key release, some other stuff. So let's actually go and maybe try to handle key press, right? So key press, and maybe in case of a key press, we can say the key has been pressed. There we go. We don't know which one. We don't know which one, but some key, any key. Right. There we go. So that's what we have. Let's try to recompile the entire thing and see if it's going to work. All right. So we probably need to get rid of the sleep. I don't think, yeah, I already removed the sleep. So here is our event loop. And let's just try to run the entire thing. How about that? Okay. I'm pressing the keys and nothing is happening. Who knows why? Who knows why? It is actually very intuitive. It is really, really intuitive, believe me. It does have a focus. So you see, it's focused right now, so I can actually switch the focus, but it doesn't get anything. Sync issue? No, it's not a sync issue. You don't understand. This API is extremely intuitive. It's extremely intuitive. So basically, before you can handle any events, you have to announce that the window handles those events. And if you didn't announce them, you're gonna not receive them. Duh! Wasn't that obvious all the time? Come on. Like, I mean, obviously you don't want to receive all of the events because it's over the network and the network connection is limited. So you don't want to receive everything. You want to receive only the things that you're interested in. So you need to announce that you're going to be handling all of that shit. Come on, people. Seriously, it is obvious. It is very obvious API. Anyway, so I forgot how to do that, by the way. I know that you have to do that, but I forgot how you have to do that. So let me see. I think it's something like select select input. Would you look at, yes, this is how you do that, my comrade. Is it a part of non-simple? Yes, I think it is a part of non-simple one, but I think after you created the window, you can then say, okay, give me those juicy events. Right, so this is specifies the connection to the server, specifies the window whose events you're interested in, specifies the event mask. Right. Okay, so a function requests that the X server reports the events associated with the specified event mask. Initially, X will not report any of this. Look. The most important sentence that you ever need while learning this entire API. Look where it is buried. I don't know how to say that word. I'm sorry, I don't speak English. Like, yeah, it's not even highlighted in any way. It's not like, it's not bold. It's not even like huge caps or anything. No, it's the second one somewhere in a paragraph of the function that you don't give a fuck about. So, all right. So, event mask. How do I assign event mask? Setting the event mask attribute to window overrides any previous call for the same window, but not other clients. Okay. So event mask. All right. Event mask and do not propagate event attributes. The event mask defines which events the client is interested in for this input, output, or input only window. Okay, so there are different kinds of windows. Input, output window, and input only window. So the event mask is a bitwise inclusive OR of 0 or more of the valid event mask bits. You can specify that no maskable events are reported to no event mask. Okay. And here are all of the event masks. Okay. So what we'll need to do, we'll need to call, what is that? I already lost everything. So here are the events, here are the other thing. So we'll need this part. So this is the event mask, we don't care about that. So this is the second thing that we'll need. We don't really care about the visuals anymore. Right, so I'm gonna close that. So there's a to mask, and the last thing I need in here is the function index. Okay, so here's the select input. So here's the three windows that I care about. Right, X select input. I think I'm gonna actually put that after I created the window, right? So after I created the window, here's this thing, here's that thing, and EventMask is going to be, I only care about key press mask right now. There we go. Cool. And now let's try to recompile the entire thing, and there we go. So the key has been pressed. We don't know which one, but some key, any key. Isn't that amazing? I think it's goddamn freaking amazing. Holy shit. So we welcome to X11 API. That's pretty pogue, not gonna lie. That is in fact pretty pogue. That was so fast and intuitive. Nice. Yeah, you're welcome. But what's interesting is that, okay, so here's another thing that you probably didn't notice. Right, so I'm starting the entire thing. Right, and I'm about to close the window. But the application is still working. And you actually have to interrupt it for it to stop working. So okay, so, and you know what's funny? In SDL, okay, so let's take a look at SdlEvent, right? So SdlEvent is actually pretty cool because it's a pretty good, event API. SdlEvent has SdlQuitEvent, right? And SdlQuitEvent is sent when the user requested to close the window, which is actually super convenient. You just can handle that event, right? And just do something before closing everything and then exit the loop and stuff like that. Cool. Let's actually try to Control F, exit, quit, close, terminate. Where is the event that indicates that you closed the window or did? Where is it? Chat, what the fuck? Where is the event? Well, I have an answer for you, my dear friends. There is no such event. So here's the thing. Unmap, maybe it is Unmap, but I'm not sure if we can handle that. Oh, maybe Unmap. Unmap modify. But I'm not sure if Unmap is a... Okay, so that's actually very interesting. So maybe I'm about to learn something new. Destroy event. There's also destroy. But I mean, destroy is probably when you actually destroy the window, right? So maybe unmap is more of a correct thing to say. So Xerror can report unmap notify events, so the client wanting information about which window has are unmapped. The Xerror generates this event type whenever a client application changes the window state from mapped or unmapped. So yeah, we can probably try to use that. But as far as I know, there is a more ideological way of doing that. So as far as I know, the idea of X11 is that it provides the mechanism, not the policy, right? So, and closing the window is actually a higher level concept than X itself, right? So, and basically the closing the window, the concept of closing the window is a concept on the level of a window manager. And as far as I know, I might be wrong, by the way, because I'm not familiar with this kind of API. I know about this API on the level of rumors and stuff like that. But in X11, you can actually register your custom events, right? You can register your custom events. And window managers, when they close the window, they send their custom close events. And because the different window managers can use different custom close events, there's a standard, there is a convention of what kind of custom close event you kind of have to expect from window managers or something like that. So basically, we actually did that in a Boomer. So Boomer is the Zoomer application that I use on my streams all the time, right? It looks like this, right? So it's written in basically X11. We are using GLX directly. And the entire application is actually written in nim, but that's not really important. So the only thing I care about is how do we handle the close event? How do we handle the close event? So let me see. So because I'm probably going to be stealing that shit from there. So here are the events. Oh, by the way, this is actually quite important to notice. We're using expanding to handle events in non-blocking manner. So this is actually quite important. So client message. Oh yeah, so this is a client message and we're looking for WM delete message, right? So in WM delete message, we're creating, we're creating an internal atom with the name WM delete window. And then we're saying that please, send us this message when you're deleting the window. And this is like a higher level concept than X itself. Right, so we can, I don't really know details on this entire thing, but I kind of want to Google it up and just learn more about it. So intercept WM delete window. So what's up with WM delete window? I'd like to intercept WM delete window that is posted to a certain selection of windows that an application am writing, so that they can act on it instead of application receiving it. So I don't know X11, but I googled intercepting WM as keyword. So there's some discussions. Right. So that's pretty cool. And then you just basically look at whether it's a client message, and then you're receiving it, and yeah, that's how you basically detect that the user closed the window, because closing the window is a higher level concept than the X. Right, it's a concept on the level of WM, on the level of a window manager, and window manager is higher in the abstraction layer. Right, so welcome to Unix, everyone. It's fucking fun. It is in fact very, very fun. So when I said that WinAPI is better than X11, so do you still think I was joking? Yes, in WinAPI you have huge functions with a lot of arguments. You also need to create a structure, and you need to fill up the structure, and most importantly you have to set the size of the structure within the structure, so WinAPI knows what kind of version of WinAPI you're running. But you don't have to deal with this kind of shit, at least. It's just more of a tedious work of filling up stuff and calling huge functions, but there's nothing like that where just things are straight up unintuitive and you just have to know that. So so it does not self-terminate. No, it does not self-terminate. But when the OS request shut down, it compiles if you implement what? Complies? OS shutdown? What OS shutdown are you talking about? I'm sorry, I don't understand. Anyways, I think we're gonna handle the destroy event after a small break, because I ran out of tea, and I do in fact need a lot of tea to deal with this kind of API. But the thing is, I really wanna deal with this API because I wanna keep this application, so the amount of dependencies for the application as low as possible, right? I don't want to depend on like a huge SDL thingy. By the way, SDL sounds like a pretty lightweight dependency, but if you take any SDL application, right? So something like, yeah, I literally have the thing called something, maybe something real right, because I need an executable. And if you take a look at what it depends on, here are all of the dependencies of a simple SDL application. It will depend on your entire distribution of Linux. Glue, GLU, so A-Sound, Pulse Audio, X11, it's all of that stuff. It's just like, yeah, it's like everything. It's literally systemd. So gcrypt, I have no idea what is gcrypt. It's like, yeah, this is your entire distribution. Well, not the entire distribution, but it's like literally everything. So in our case, if we take a look at our executable, right? So there's no any particular reason why I want to keep the dependency low, but it's a recreational pet project, right? It's a recreational pet project, and it's also a research project. So why not? Why not keep the dependency low? Why systemd? I have no idea. Because computers in 2021. Waiting for X11 for X11 persist between shutdowns. In fact, it continues while your PC is off. Nice. That's a pretty cool feature. Oh, so the window manager standard refers to. Okay, thank you. So it is a thing. So I'm not imagining that. Right, so there is a standard for window managers, and they do mention that specific thing in there. How is it called? I already forgot how it's called. Delete window. Okay, WM delete. Yeah, there we go. So, and I suppose the standard also defines a bunch of other, window manager related things that you can also catch. And what's interesting, that creates such a weird situation. What if we didn't have this standard and each individual window manager would use whatever the events they want? And you will have to write an application that needs to support and needs to work in all of the window managers, so they will all have a huge switch. Maybe that's exactly what's going on already under the hood. Who knows? Because we quite rarely go below SDL or below JTK or below Qt. Maybe that's what these frameworks already do. Maybe that's already the case. So, who knows? Maybe there is a bunch of competing standards for window managers, and all of these frameworks that we rely on have to depend on, have to support all of that. And it's just we are not aware of it because we never think about it. So, yeah. That would be interesting. It begins. And also, by the way, all of that should be actually written with Zalgo. So, right. Yeah, so it should be written like that, I think. Maxi fuck-up, there we go. So that's the standard window manager event. So that's the standard window manager event. Anyway, what I wanted to do, I wanted to make a small break because this kind of shit is actually exhaustive, believe it or not. So working with this API actually took away a couple of years from my life, straight up. So let's make a small break and. All right, let's continue. So before we continue, I would like to actually post this thing to the description for people who's watching on YouTube. Right, so the standard that describes the WM delete window event. Right, so I'm gonna put this in here. Thank you so much for whoever posted that in the chat. I don't remember your nickname, but I do really appreciate your help. Thank you, random user from the chat. That is very, very cool. All right, so delete window, save yourself. Take focus, save yourself. Why is it so funny? All right, so, and we have a couple of examples on how to handle this thing, right? So, so first we map the window, then we have to call something called, it's so ominous, it is in fact very ominous. Save yourself. Xintern atom. So what's up with Xintern atom? So you can actually have several of them, intern atoms. All right, we need a single one. Only if exists. Okay. So returns the atom identifier associated with a specified atom name string. If only if exist is false, the atom is created if it does not exist. Therefore, X11 App can return none if the atom name is not in the host portable character encoding. Yes, of course, I knew about this thing. So host portable character encoding. Okay, the result is implementation dependent. Like, to be fair, every time I'm trying to read Xlib Manual, I feel like I'm reading the lore of the Elder Scrolls. You know what I'm talking about? Has anyone played the Elder Scrolls? Basically, in Elder Scrolls, you can open any book and you start reading it and you read a gibberish like that. And over time, the more gibberish you read, the more it kind of starts to make sense because you start to connect these weird words together. It's like, what the hell is host portable character encoding? So it does feel like the Elder Scrolls lore to some extent. I don't know. Anyway, so yeah, let's go and do that. So we have to map the window, then we set this thing to false, right? If I understand correctly, right? So I suppose I'm gonna just do that. WM delete window, right? Yes, I just copy-pasted a code from Stack Overflow, and I wonder if it actually got into their analytics, because as far as I know, Stack Overflow like has telemetry, and they even like tracked how many times a particular piece of code was copy-pasted. So yeah, I just increased the copy-paste count for this specific piece of code. That's precisely what I did. So this thing returns an atom. An interesting thing, I'm really curious, what the hell is atom? Right, so let's actually try to build the entire thing. Now it is 2, right? Yeah, very funny, because nobody's using this thing except me. Yeah. So god gdb, and let's try to run it. Let's do break main. Let's run this entire thing. If I do display, here is my display. Then if I do display window, there we go. So we have a display, we have a window, and I also want to display WM delete window. So, and then we set it, and we do have something. So specifically that atom has a number 398. I don't know what is that supposed to mean, but it is what it is. And then we continue doing things. Okay, so now I know that the atom is basically a number, whatever that's supposed to mean. Display. I mean, the first display was the command of GDB. So display, in fact, where is it? I don't see it. Display. The first one was the command of GDB. The second one was the variable in my source code. So that's how it goes. Okay, so after that, I need to use a function called set WM protocols. WM protocols. So what this function does? Function replaces the WM protocol property on the specified window with the list of the atoms specified by the protocol arguments. If the property does not already exist, xset WM protocol sets WM protocol property on the specified window on the list of atoms specified by the protocol arguments. The property is stored with the atom of atom and a format of 32. If it cannot in turn the WM protocol's atoms, set WM protocols returns a 0 status, otherwise it returns non-zero status. Of course, well, I knew that. So this is what we have to call in here. So essentially, if I understand correctly, what it does, it says that when you receive WM delete window, right? So send that thing to me as an event, right? So we provide the display, we provide the window, and then for the protocols, yeah, we have to take a pointer to WM delete window, and one is like a count, right? So it specifies the number of protocols in the list. Oh, you can actually set several of them. Okay, so in our case we set, okay, so you can actually initialize like a bunch of atoms, right? You can initialize a bunch of atoms, and you even have X in turn, intern atoms to initialize like several names simultaneously, and then you can set several of them simultaneously. Okay, so that makes sense. Basically, you announce that this is the events that you want to receive from the window manager layer, if I understand correctly. It's just worded in a really weird way, but it is what it is. All right. So now the type of the event that we're looking for is actually client message, right? It is a client, yeah, it's a client message. There we go. And in case of a client message, right, so we have to take the event, reinterpret it as a client event, right? We're reinterpreting it as a client event, and I wonder if I have some stuff for that. So is there a client? Okay, so this is the event. So X event, maybe I need to find the definition of the event structure, right? And here is the event structure, and the client message here, it is client message event. And if we take a look at the client message event, what do we have in here? We have the message type, which is the atom, right? The one that we actually set in here. So we're interpreted as a client, then we take the message type, and if the message type is equal to WM delete message, the one that we created and announced, that means we want to set quit to true. And once we set quit to true, it will basically close the display and quit appropriately. WM delete and save yourself. Yeah, something like this. All right, let's try to recompile the entire thing, and okay, that didn't work. Event has no member client. That is really weird because it's a X. Okay, so it's a X client, and then it's a data. Well, that was really weird. What I was looking at in here then, because that made so much sense that I'm. Oh, it's a union for these several things, and it's just like, really? I'm confuzzled. Oh, it is X client. Okay, so maybe I can just rename it to X client, and that's gonna be fine. And then if I close this thing, nothing. Oh, it can't even close itself. Okay. Huh, that is really weird. So that probably means that. So we probably have to look into this data L thingy, even though I'm not quite understand what the hell is that. So data L 0, it's just a bunch of unions or something like that, so you have to extract this stuff from there, and now you can actually close yourself. That's perfect. But also one of the things you have to do, you have to reinterpret this thing as an atom, because it's not an atom by default, but it is what it is, and now I can handle like go delete yourself. So finally we're able to create a window that can catch the key presses and stuff like that, and it can also close itself when the user actually asks to close that window. So yep, we're probably not going to handle key presses too much, but I just want you to handle them just in case, just to demonstrate how it all works. So that's pretty cool. So the next thing we need to do, we need to somehow display something on the screen. And the way you do that, as far as I know, in X11, one of the ways to do that, probably not the fastest way, but we're gonna try it first, is to export image. Right, we have an image, and we want to put that image to the screen. Right, so this thing accepts the display, the drawable. And by the way, you can put a window in the place of drawable. Windows are drawables. So here, in fact, what we say is that it accepts a window. And the next thing it accepts GC. And no, GC is not garbage collector. It is a graphical context. Right, it's actually kind of similar to the Windows GDI thingy, right? In GDI, you also create some sort of like a graphical context, and you use that graphical context to bleed the images or to draw lines and stuff like that. This is actually kind of a similar thing. It's like a mirror API. So, and yeah, you will first have to create that graphical context. So let's go ahead and do that. So let's just see what it takes to create a graphical context. So it takes the display, the drawable. As already mentioned, window is a drawable. So you're creating a graphical context for a specific window. And then you accept two things called values and value masks. So this is actually a common pattern, and I think even WinAPI uses a similar pattern. So you have a structure that denotes the arguments that you want to set, right? So basically all of this stuff could have been argument of the create GC function, but since there's so many arguments in here, they decided to group it into a structure. And what's interesting is that not all of them you want to set. Majority of them you want to actually use the default one. So to indicate what arguments you care about in this whole structure, you have to pass a mask that each bit corresponds to the field in this structure. Right, so look, there is a GC function bit, and here is the function field. So the next field is plain mask, and here is the plain mask bit. So essentially you allocate the structure on the stack, you set the fields that you care about, and then through a bit mask you tell the X11 what fields to actually initialize from. Right, so that's basically what it is. So I think even WinAPI uses a similar pattern of you know, of compressing the amount of arguments, because you can actually configure so many things. As far as now, does Vulkan use a similar pattern as well? Because in Vulkan I heard there are huge structures, right? So you pass huge structures to the function calls. Do you also use like a bit masks to describe what fields to use and what? Can you still use these types after function decal thing in C++? I kind of like it. I don't think you can do that. I thought it's like done purely for readability or something like that. I just basically ignored it, to be fair. But we can try to see if it actually matters or not. So let me try to rebuild the entire thing. All right, so let's just see if it compiles, and we can grab one of the existing functions, for example, this one. Right, so I'm gonna copy this stuff. So we need to remove the types from here. All right. I'm actually curious. So you can do that in C++ apparently, right? So, and in here we have to turn this into a list. So maybe I'm gonna actually do something like that. Then I'm gonna use a little bit of Emacs magic, like so, a boom, and if I, okay, so that's fine. I suppose this is how we do that, right? So. Okay, I didn't know that you can do that in C. It's a C9. Yeah, it looks like, it feels very 98-ish. It feels very 98-ish. And to be fair, it makes sense. It makes sense because the X11 is a very old API. It lets you compress the huge signatures, I suppose. All right. Sort of. Okay. So what I was doing, I wanted to create a graphical context. That's what I wanted to do. So I don't think I'm going to be initializing graphical context in any specific way. So I'm gonna create it somewhere here. So we have we're gonna have a GC. We provide the display. The window is gonna be drawable. So I don't think I care about any of this stuff because we're gonna be using that to just bleed the images. So I think I'm gonna set the value mask to 0, meaning that I don't care about any fields in this particular structure, and I'm gonna just don't pass the structure. So I think if the mask is 0, it's not gonna even try to dereference this entire thing. So let's try to recompile the entire thing, and there we go. So now I can just verify everything in the debugger. So let's break on main and run the entire thing. So let's go here. And if I print actually display GC, so GC is it's some sort of structure, right? But it's also a pointer. So is this an opaque pointer? Yeah, it is an opaque pointer. So you're not supposed to look inside of it, but it created something. Right, so it exists somewhere in the memory, so which is fine. Okay, so I suppose in case of an error, createGC would return maybe null. Right, does it return null? So it will probably generate some of these error messages, and when it generates error messages, I think Xlib actually prints them to the standard error or something like that. So yeah. Okay, so we have a GC. So once we've got that, we should be able to put an image, but we need to have an image, right? So we need to create X image first. So this is a structure, and there is a way you create an image. So init image, get image. If I remember correctly, the function that you use is create image. Yeah, it's called create image. Right, and here what you provide the display, the visual, by the way. Remember we were talking about the visual, right? Visual is the way of dealing with visual aspect of the screen, right? But we never actually set the visual for the window. We went a very easy path of just calling CreateSimpleWindow, and we don't have a visual because it just picked whatever visual like it found in a root window or something like that. So how can we get the visual of that window just to be able to create an image that is with compatible format with the window itself? That's a good question. That's a very good question. Well, in X11, you can actually query the attributes of the window, and visual is one of the attributes of the window. So I think it's something like get window, get window attributes. There we go. So basically there's this huge structure which are attributes of the window. Right, so what you can do, you can allocate this structure on the stack and then use the function get windows attribute, providing the connection and the window and the pointer to the structure. And what this function will do, it will grab all of the attributes of that window and fill up the structure for you. And one of the attributes of the structure is the visual. Yeah, so it's actually feels very Vulkanish. So yeah, I guess Vulkan is just using very old C style API, right? Because this kind of style of API have been for decades, right? So yeah, and so and this is precisely what we're going to be using to get the visual, and we basically have all of the necessary information. For example, do not propagate mask or overwrite redirect, you know, all of these intuitive names. Your EventMask. Where is our EventMask? Okay, comrade. All right. So let's go. So first I need to probably define this structure somewhere. All right, so here's the window. I'm gonna call it WA. Right, and there we go. Here is the structure. We're gonna also zero initialize it on the stack like this. Then we're gonna call this thing, right, provide the windows, provide the display and the pointer to VA. And we can verify yet again in a debugger that all of that is going to work. So if it actually grabs any parameters in here, so it's going to be GDB, right? And I think in here I can just say God break, and it will set the break in the cursor, right? So I started to recently use the Emacs integration with GDB. It is not really fancy, right? Because you still work directly with GDB, but it integrates with Emacs in the sense that it displays within the Emacs, and it also has the feature of I can put cursor in here and then say break, and it will say the breakpoint in that specific place. You see, it's not fancy, but it just like extends it a little bit and hooks up into Emacs, right? It's like something like that, right? So, and I don't really need more than that because it's actually rather convenient, because quite often I want to just, okay, let's break here, right? And then I'll have to look up, okay, so here's the name of the file, here's the line, let's go there, let's type it there. Now I don't have to do that. Now I can just say break here, so which is rather convenient. Okay, so let's just run this entire thing, and it already broke here. Let's display VA, and as you can see, we have a gibberish, right? So we have a gibberish on the structure. Then we do next, and now we have something that kind of makes sense, I suppose. Maybe not, because it got 0 initialized, and now after this call, it got populated with all sorts of goodies. So we have window size, width and height, which is correct. We have depth 24 bits, and here's the pointer to the visual, right? So that means I can take WA visual, and then if I dereference it, here is the visual. So visual contains the information about like masks and stuff like that. So I suppose if I print this entire thing in hexadecimal, yeah, we clearly see that the mask like points to the specific bit of the component. So FF000, FF00, FF, and so on and so forth. Okay, so everything seems to be okay, and we successfully got the attributes of the window. We now have the visual that we want to use for the image, and we have the graphical context. Okay, so what else do we need in here? So we're just trying to create an image. Where was the create an image? I probably already closed it. So let's close all of that. Create image. So yeah, we have display, we have visual, we know the depth, so we probably can get the depth from the window attribute as well. So the format, oh my god, this one is so good. The format of the pixels, right? So here you pass the pointer to the pixels, but you also have to specify the format of the pixels. And the format of the pixels can be of 3 kinds: XY bitmap, XY pixmap, and Z pixmap. Guess what this shit means? Try to guess it. So this is the format, and the format can be XY bitmap, XY pixmap, and Z pixmap. And try to guess which one do you need. You would never believe which one you need. Here's an interesting thing. Okay, so here is an official Xlib Manual. So this is basically the same thing, but in PDF, and from the official website of X Consortium or whatever. So let's try to search for something like XY bitmap. This is not how we do that. Ah, shit. Okay, I need to. Well, that was weird. One more time. Mu PDF, Xlib PDF. There we go. XY bitmap. All right. So it's mentioned in the image format, right? So eventually we'll find the list of all of the possible formats and the descriptions of what they mean, right? So if I were writing documentation and I was referring to this kind of formats, I would make a list and just explain what each individual thing means. Okay, so XY bitlib. So if we go down, if XY bitmap format is set, the depth of the image must be 1 or a bit match error results. So it doesn't really explain what is XY bitmap. Okay, let's actually keep searching. So specifies the format, you can pass XY bitmap or anything like that. And that is it. there is no explanation of what is XY bitmap, XY pixmap, and Z pixmap in the entire official manual of Xlib. They just mention these three things and they don't explain what the fuck is that supposed to mean. Like what's the difference between them? They just mention them. So you can put these three things in here and yeah. The thing about this stuff, you have to search in the protocol specification of the X. Right, because this is Xlib. Xlib is a library that helps you to write X11 applications, which are network applications, which you have to write by connecting to the X server via the socket and sending binary commands. So each individual function in here corresponds to a binary command that you send over the X wire. Right, so Xlib itself doesn't explain you much, it just explains you the interface. The actual meaning behind these types is actually in the protocol specification. So, let's take a look at the protocol specification. So, as far as I know, protocol specification is an RFC. Protocol RFC. So, I don't remember, it's 10.13. So, I have a special mode for reading RFC. In Emacs, which is quite convenient. This is actually a pretty cool mode. It basically searches for the RFCs and it downloads them and caches them on your machine. So, and then you can just open it, it will download it and cache it on your machine. And there we go, we have a RFC. So we can search for things like XY bitmap. So, okay, so there is a such notion as XY format. XY format. The data for a pixmap is said to be in the XY format if it is organized as a set of bitmaps representing individual bit planes. Okay, so we need to understand what is a bit planes. Bit planes. So it's a very old thing. As far as I know, bit planes refer to the very old hardware that worked in a very particular way that I don't really understand. I'm not going to pretend that I know how this kind of hardware worked, but they used something called bit planes. So the idea basically, yeah, so the method of calculating is to compare each pixel xy to 3 adjacent pixels. And if the pixel is the same as the least 2 adjacent pixels, it is not noise. And that's why they're called XY, because very old VGA. Okay, so it's a very old VGA. Basically, everything that starts with XY, you probably don't need to think about it anymore. So in our case, you have to use zpixmap. If you guessed what kind of thing you have to put in the format, and you guessed it zpixmap, you won. This is the one that you have to use, because XY is referring to bit planes, something that you don't really have to worry about 2021. So, and nobody, literally nobody, is gonna explain that to you. This is so bad. And why is it called zpixmap? I have no idea. Why is that zpixmap? What's the difference between bitmap and pixmap? If I remember correctly, since it's a client-server application, I think the main difference between bitmaps and pixmap is that one is stored on the server, another one is stored on the client, or something like that. I think it just depends on what's it's really weird. I still don't understand what's the difference between bitmaps and pixmaps in X11, but there is some kind of a difference. And I tried at some point to dig into this like thing, and they drove me mad completely, and I lost shit ton of weight, as you can see. So if you want to know why I lost so much weight, it's because I was trying to understand this and I couldn't. Anyway, so yeah, that's basically what we need to do. We don't have to worry about this thing, we just have to set it to zpixmap, and the rest is pretty much straightforward. Bitmap is just a monocolor and pixmap is with color. Okay, so thank you so much. I'm gonna gain my weight back. All thanks to you. So let's go. What we need to do in here? We need to create an image, right? So so when I create the image, do I need to specify GC? Okay, so we can actually create an image before I specified GC. So this is the image. We provide the display. The visual is located in VA. I think the depth is also located in VA. We already established that the format is zpixmap. zpixmap. So what's the offset? Offset specifies number of pixels to ignore at the beginning of the scan line. I don't think we need to ignore anything, so I'm going to set it to 0. So the data, where do we store the data? Specifies the image data. So I think that the place where we store the data is grid px. Yeah, there we go. This is where we store that. So I'm going to set grid px. Width and height, I suppose, is the specified width height in pixels, right? In our case, this one is a grid width in pixels and grid height in pixels, right? And grid is basically the result of our renderer, right? So this is the result of our renderer. Scanline, okay, bitmap pad specifies the quantum of a scanline, 8, 16, or 32. In other words, the start of one scanline is separated in client memory from the start of the next scanline by an integer multiple of this many bits. Of the integer that is multiple of this many bits. So I suppose our pixel is actually 32 bits. So I'm gonna put 32 in here. 32 in here, and bytes per line specifies the number of bytes in the client image between the start, and so basically this is like a stride or pitch or whatever you're supposed to call it. I remember like there was a difference between stride and pitch, but I don't quite remember that difference. So in our case, I think this is going to be basically grid width multiplied by the size of RGBA32, right? So that's basically what it has to be. Right, and that theoretically should create the image, right? It should create the image. Hello, Freefu, welcome to the stream. So let's recompile the entire thing. So grid, okay, so I probably have to actually do something like this. Okay, so that looks cool. Let's do God, not God break, but God GDB. It's a God debugger. It's a God debugger. Okay, and maybe here I want to break. All right, and let's just run the entire thing. I'm gonna also display the image. The image looks fine, I guess, not really. And we're gonna call it. And here is the pointer to the image. We can try to look inside of that image. And what do we have? So we have width, which is 100, you know, basically full HD. X offset is 0, format is 0. So we have the data, which points to the thing. Bitmap unit, which makes sense. All of that kind of makes sense. All of that kind of makes sense. And we also have F, which points to different functions to create image, destroy image, get pixels. So this is some sort of a polymorphism that I don't really care about, but looks fine, and there's also masks in here. So if I actually print it with X, so I suppose those masks like red mask, green mask, and blue mask were taken from the visual, right? So as far as I know, for creating an image, the visual is only needed to obtain those masks, right? And if I understand correctly, we use precisely these masks to, you know, well, if we don't, we can actually change the way we generate things, so it doesn't really matter. Okay, so everything seems to be okay, and if I just run the entire application, yeah, it works fine. There's nothing, you know, that breaks in here. Okay, we created an image, we created the GC, and now what we need to do, we need to try to display the image, right? We need to put it into the window, right? So let me see. So X put image. Let's see if we can do that. So the only thing we need to have in here is the display, the drawable, which is the window itself, the GC, we do have that, the image, we do have that, the source position, right, so we can set it to 0, and the destination position, we can also set it to 0, so basically you can draw sub images, and width and height is how much of the sub image you want to draw. So everything this function requires, we do have, and we're ready to try to bleed our image, our grid into the screen. Okay, so let's go ahead and do that. So I'm very excited. So I wonder, when do we have to do that? Do we have to do that after we map the window or not? So I'm gonna actually do that after we map the window, but before we did the synchronization. Right, so here is the display, then we have a window, then we have a GC, then we have an image. So the source is going to be essentially 0, 0, right? So here's the 0, 0. The destination is going to be essentially 0, 0 as well. The width is going to be grid width in pixels, and the height is going to be grid height in pixels. There we go. So this entire thing should just finally put the image that we created on the window using the graphical context created for that goddamn window. What kind of image this method accepts? Only bitmaps? I think it also accepts like bit planes or whatever. I don't know. There's 3 formats or something. And I think this is not going to work. Because you know why? Because we have nothing in the grid PX. Grid PX. Yeah, we have nothing in here because we didn't even call into our renderer. But the reason why I want to do that anyway is because I want to test it, right? So let's actually try to run it, I think, and nothing breaks so far, which is nice. Okay, so now we need to call to our renderer. So our renderer works like this. So here's our renderer. And what I'm thinking is that maybe we can extract this entire thing to something like render grid px, right? So this is going to be render grid px, and this becomes a separate function, right? And then a render grid px. There we go. So here's the function. So we're gonna call this function only once before the execution, just to fill it up with something. So render grid px. There we go. And let's just try to see what's gonna happen. There we go. We did it. So the renderer generated the bits into the buffer. We did all of the ritual dances to satisfy the X11 gods to bring those pixels into our screen. And of course, we probably have to do that on each exposure of the window, right? So, but there we go. We managed to do that. In 2 hours, it took us 2 hours to prepare all of the necessary machinery to just take our pixels and display them on the screen. Isn't that amazing? Isn't that amazing? God damn! So, the X11 gods have been defeated. Yes, exactly. Alright, so there is an event called exposure, as far as I know. So X next event. Right, so in here, if we take a look at the events, exposure, yeah, so this is the expose event. So X server can report expose event to clients wanting information about when the contents of the window region have been lost. The circumstances in which the X server generates expose events are not defined as those for other events. However, the X never generates expose. Anyway, so basically it's like a repaint event, right, in some other systems. And what we want to do in here is probably first declare that we want to receive the exposure event, right? So X select input, we receive key presses, but we also want to receive exposure mask, right? Exposure mask, right? And in here, we're going to have case exposure, right? And every time, you know, an exposure happens, we want to put the image to the screen. Maybe after that we probably also want to sync the display just in case, without losing any events or anything like that. Well, we can try to. So I suppose it's not called exposure. I think it's expose. I think the compiler actually tries to tell us something. Okay, so, and no matter, okay, that's pretty cool. All right, so here's the entire thing. And no matter what you do in here, as you can see, it redraws everything automatically, and we have this beautiful, beautiful thing in here. So that's pretty powerful, not gonna lie. But this doesn't really feel very animated. So OpenGL implementations on a draw call must get the pixel data from the GPU and send it to Xserver like this. Maybe there are actually several ways to send pixels to X11. This is not the only way to do that. As far as I know, a faster way would be probably to have a separate PixMap. Right, so there is a thing called PixMap within X11. Create PixMap. And what's interesting about PixMap, it's like a window that is never visible, but it is drawable on. Right, so essentially, you can use the same calls like export image or draw line or whatever on the PixMap as well as window. So you can basically render the frame from images into PixMap, and PixMap has a super fast way of just bleeding its contents on the window. So thus creating some sort of like a double buffering effect, but don't quote me on that. I don't really know much about X11. And on top of that, there is a special X11 extension that enables faster double buffering. So X11 double buffering extension. So having double buffering in X11 was such a common thing that they created a special extension for the protocol that allows you to do that easier and faster. So it's basically specifically optimized for that. So there could be a lot of like different things that you can do. So anyways, and specifically for OpenGL, I think there's also, you know, GLX extension. All right, but again, I know nothing about this kind of stuff. So I want to first try to make the size of the renderer a little bit smaller, right? So I want the size to be around 800 by 600, right? So I know that the size of the single tile is 64, so maybe maybe I can do something 64 by 13. All right, so this is going to be 13, and so this will be 60, 64, 64. Okay, so we can just set that to 10. So I just want to make it a little bit smaller, right? So it actually fits in here. So that's basically what I wanted, right? Now I want to actually constantly redraw the image, right? Right now, next event actually blocks until it receives the event. So that means we have no opportunity to constantly redraw this image or animate anything. Right, so one of the things we want to do, we want to replace XNextEvent with XPending. We already saw that function before, XPending. So this function returns the number of events that have been received by Xserver but have not been removed from the event queue. So essentially that way, if you don't have any events, right, if you don't have any events, you may not even try to do next event, so you don't block. And I think in the Boomer we already did something like that, right? So let me actually steal some stuff from the Boomer. And by the way, I think I actually forgot to put the Boomer in the description for people who's interested in this kind of stuff. The Zoomer application for Linux. All right, so it's Boomer. And you find it in here. And for people in the chat, yeah, here it is essentially. So I did a lot of X11 for this specific thing, so I'm going to be basically stealing some stuff from it. So expanding. So while oh yeah, so basically while you have some events in there, you call to next event, and you can be sure that this call is not going to block. As soon as you ran out of the events, any call to next event will block, and you don't want to block. You want to quickly quit this entire loop and just draw the frame or something. That's basically what you want to do. That's the idea. Okay, so let's try to do something like that. So here's X event, and while expanding, right? So, and as I already said, expanding accepts the display, right? Display greater than 0, right? We try to call to the next event and just process the entire thing. So since I'm going to be constantly redrawing the frame, I don't really care about the exposure, right? So I can just ignore the exposure completely. I'm going to put the drawing in here. So I'm not sure if I need to synchronize everything at the end of this thing, but we can do that. We can just synchronize it just in case. So we don't need to handle exposure, and since we don't need to handle exposure, I'm going to actually remove it from the mask, so we never receive that event at all, because again, this is a client-server application. We are connected via the network bandwidth is limited, so we don't want to waste the network bandwidth in 2021, right? So that's why I'm gonna mark, so I don't care about this event. Please don't waste the bandwidth. All right, so that's basically the loop that I want to organize, right? So we try to flash the whole queue, and once we flash the whole queue, we are rendering the image, right? So we're rendering the image constantly without any synchronization or anything like that. Okay, let's see how it's going to look like. Doesn't look that bad, right? So it's only flickering when we are resizing everything, but apart from that, it is not really flickering, which is nice, I suppose. I wonder if it will start flickering when... Oh, we didn't really actually redraw anything. Oh, and by the way, so I was about to actually do the following thing. I was about to set a render grid in here, but it is actually kind of dangerous. I'm going to show you why. Because in the rendering, we have a profiler which collects information about, measurement or timing measurement of the rendering phases. So, and if we don't clean that information, it will basically overflow. Well, that is very interesting. It doesn't really overflow. Oh yeah, it overflew. So it overflew the summary information, because the summary was, oh yeah, it's actually like 1,000 times. Yeah, so basically every time we do the rendering, it collects the profiling information, right? So, and we don't really care about profiling information, so what we want to do probably, we want to completely disable the profiling for this specific case, right? So I'm going to go in here and I'm going to say don't have any profiling, just disable the profiling, and let's go. Okay, so this one is interesting. So it constantly generates a new frame over and over again. Yeah, it's doing it relatively fast. There is a little bit of tearing that I can see, but so interesting. What if I enable optimizations? Because right now everything is super slow, right? Everything is super slow. So if I optimize it as much as possible, is it going to be faster? It's hard to tell if it's faster or not. So, right. Let's keep it as 0. The next thing I need to do, I need to probably not regenerate the grid itself, if you know what I'm talking about. Right. I probably want to generate the grid once, and only re-render the grid, and also re-render the atlas. So I think what I'll need to do, I'll need to split those phases into separate functions. Okay, I already have a generate atlas, and I need to introduce something like render grid and generate grid. Okay, so let's do the following thing. I'm gonna do generate grid. So generate grid, and I'm going to basically copy paste the entire thing there. Okay, so here's the generate grid. Generate grid, and I'm also gonna have a render grid, which is gonna be something like this. We have a little bit of a confusion. So render grid. There we go. So here's the render grid, and oh shoot! Did I lose that? Oh my god! I think I lost that information. I should have copy pasted it there first, right? So and then I'm gonna paste this thing in here. There we go. And then I'm gonna take that stuff. Render grid, right? Is it called render grid? Yeah, it's called render grid. So here are like separate things in here. So unfortunately, this thing, oh boy, I'm not sure how easy would it be to. Let's go and just actually inline it, because I don't think we'll need that function anyway. So I'm gonna bring this entire thing back here. There we go. So here's the full rendering and stuff like that. And the only thing I care about in here, right, is I wanna generate grid once, right? I generate grid once, and on each frame I only generate atlas, which is actually render atlas, and then render the grid with the new atlas. So the thing I want to do, actually, I want to rename generate atlas to render atlas, because that's what it is. Right, so render atlas, boom, boom, boom. Okay, there we go. So that makes a little bit more sense. Cool. So the reason why I was doing all of that is because you saw how it constantly just generates a new grid. And this is because we're regenerating it on each frame. Let's generate the grid once, and on each frame only re-render the atlas and the grid. Right. So for those who doesn't know, atlas is basically a full set of tiles, right? So this is the tiles that you can have at all. And grid is the thing that we build out of that atlas, according to this grid. Right, so atlas is basically like a sprite sheet. So we first generate the sprite sheet, and then using that sprite sheet we fill up the whole grid. So this is how it works. That's why it works so fast, because generating grid, we don't generate grid pixel by pixel, we generate it tile by tile, and we pre-generate the tiles out of pixels, and we basically quickly bleed those pixels into the final canvas. So that's how it works. Right, so and basically here I only generate grid once, so it's gonna stay the same, but the atlas is gonna be different. Right, so the atlas is gonna stay different. All right, so as you can see now it stays the same. It stays the same. Will the sprite sheet be the same time you call the render atlas? Yes. Right now, but later I'm about to change that. So I'm about to actually make it different every time we render it. So I don't really know how to animate the black and white thingy, right? But I do know how to animate the blob thingy. So digits, let's actually switch the shader to the blobs. And the colors, right? So we have a bunch of colors in here. So which colors do we want to use? I want to use these colors. Right, so yeah, we're gonna have a different shader in here. So here it is. I kind of rather prefer. So this is the. Is it really? It's a red in. Oh shoot! This is supposed to be red and cyan, but it looks like a blue and yellow. You see, this is red. And this is cyan, but why the fuck? Okay, we already found a pretty interesting bug in here, right? So, yep. But maybe it doesn't matter right now. So it's probably BG. Yeah. because the order of the bytes are different for X11. Yeah, the order of the bytes are different. Black and white doesn't matter because all of them are either FF or 00. So that's why the order of the bytes didn't matter. But when you get to actual colors, it starts to matter. So okay, the thing is, what I want to do, let's fix that a little bit later. So maybe I'm gonna put the to-do in here somewhere in the main, right? So where is the to-do? When we create an image, okay, so the byte order of the pixels differ between the X11 and our renderer, right? So it is important, but it's kind of a distraction right now, right? So first I want to try to animate something, and the question is how we're going to be animating everything. So we have a sort of a shader function, and what it has a parameter radius, right? It has a parameter radius. And what this parameter does, it defines the radius of that blob. If I make the radius twice as small, the blobs will appear smaller. There we go. If I make it bigger, the blobs will appear bigger. And as a matter of fact, they will actually start to, you know, interrupt each other, which looks kind of interesting if you think about it. So there is, yeah. All right, I'll think about it. But the idea is, what if we animate those things? What if we animate the radius of these blobs? What do you think? So one of the things we can do is maybe have a global variable that determines the current time in seconds. So all of the shaders can use that variable to animate themselves. Right, so this program is so simple, that's why I'm using global variables, right? So it's literally a throwaway code, so it doesn't really matter. So we're gonna have something like a time uniform, right? And initially it's gonna be like 0, right? And now, what I wanna do, I wanna somehow get the current time in, I guess in milliseconds. So one way we can do that, we can use the similar approach as with the profiler. In the profiler, we just use clock get time, monotonic time, and then we can convert it to floating point and whatnot. So maybe that's a good idea. I'm not even sure. So what clock get time actually returns? I don't quite remember. Does it get the time since the execution? So let's do man get clock get time. Clock and time functions. The function. Okay, so what about get time? Retriever set the time specified clock ID. Implementation support monotone that cannot be set and represents monotone since some unspecified starting point. This clock is not affected by continuous jumps and a system time. I guess it's fine. I guess it is. Right, so we can get that time right and set it on each frame. So the way we're gonna do that, so I'm gonna even steal some stuff from the profiler. So this is gonna be now, right? And the now is going to be this thing, I suppose. Right, so here is now. Then I know that in now we have TV sec and nsec. All right. So that means TV seconds, right? We convert it to the float, right? Then I also take TV nanoseconds, and do I care about nanoseconds? I don't think so. I think I'm gonna divide it by 1000 and get milliseconds. actually microseconds. Then I divide it by another 1000 and get milliseconds. And after that, I'm going to multiply that by this thing to actually convert it to like float and milliseconds. And this is going to be the current time. So float time uniform. Okay, time uniform. Right. So there we go. So this is going to be our current time, and we're using PostX API to set that time. All right. So in a Wang blobs, we're gonna be oscillating from basically -1 to 1. Right, so we're oscillating from -1 to 1. And how do I want to oscillate? I think the maximum is going to be half, right? So the maximum is going to be half, and the minimum has to be like 25. So I want to oscillate between 25 and 5. So because of that, so sine is not particularly well suited for that because it's a value from -1 to 1. We want to do a usual trick where we map it to 0 to 1 by doing something like this. And maybe after that we can lerp this entire thing from 25 to 50, like so. Right, so I guess that's a good way of doing that, more or less. It may slow down everything because there's a lot of like computations and especially sine. So the whole rendering could be slower because of that, but who knows. And by the way, this has to be lerp. There we go. So we are sort of trying to animate this entire stuff, and shit. It is working. What the fuck? It is so smooth, holy shit. Okay, so can we make it a little bit faster now? Like twice as fast? Well, we need to know how slow it is, to be fair. So what about 4 times? Yeah, it's like blur animation. This is super cool. I like that. We can now make it go from 0 to 1. By the way, keep in mind, this is without OpenGL and any GPU acceleration, entirely on CPU. Entirely on CPU. This is what's cool about it. Oh fuck. This is so fucking cool. What if we make it slightly slower? Let's actually go twice. In terms of the Wang digits, I think we also have a radius for Wang digits, so it's a 25. So if it's greater than 25, okay, so maybe we can actually put this radius in here. Right, so, and put it like that. Let's actually go back to digits, blobs. Right, so it's gonna be digits, and the colors. Right, so we're gonna set the colors back to black and white, but we don't really have a way to animate anything yet. So for the digits, I can also try the similar thing. Right, so I'm gonna set it like that, and it's gonna go from 0 to 25, I suppose. Right, so let's give it a try and see if it's gonna do anything. It's a little bit choppy for some reason, but I'm not sure. So what about like half now? This is love that. Holy shit. This is in fact very trippy. It is in fact very trippy. Okay, so we can make it like a bit faster, so maybe that's... One second, is this maze pro... well, yeah, sure. Okay, so let's try to increase the resolution a little bit. All right, so we have 64. We can have bigger tiles, for instance, I don't know, to 128. So let's see how slow or fast is it gonna be. So maybe for the digits. So let's go like maybe 1. I need more profiling information for this kind of thing, but what about to draw the screen using? Yeah, I'm using Xlib specifically. Well, to be fair, to render the entire image, I actually render it pixel by pixel in a back buffer in a memory, and then I just bleed it using Xlib. So yeah, that's actually super freaking cool. Holy shit. I'd like to know the performance of this thing. So, yeah, let me try to take a look at the performance. I'm gonna put it like that, and then I'm gonna enable the profiling. Right, so the... Oh, this is without any optimizations, by the way. So we put 0 in here, so all of that works without any optimizations. So anyway, I just want to take a look at the renderer. And yep, so it is still relatively fast, I would say. So if I do Wang, right, the rendering, oh, the rendering is actually super slow because of the sign. The rendering is rather slow, so it's already lower than 60 FPS. Well, this is because we're not optimizing anything, right? So let's enable optimizations. Right, so this is going to be 3, and let's just do the run. So this value have to be below 0.16 for 60 FPS performance. It has to be below 16. So let's do no build run, and let's see if it's going to be below 16. Well, it's kind of close, but I think Sign ruined it. I think Sign straight up ruined it. So if we can find a way to animate this shit without the Sign, right, a little bit faster, that would be nice, because Sign and Cosine are very, very slow. So, but they also look nice. They're the most nicest looking functions. So one of the things we can try to do, we can probably come up with a sign lookup table to speed things up, like with the lower resolution, if you know what I'm talking about. Right, so it's not going to be as smooth, because again, we have a smaller amount of entry points. By the way, what is the best way to interpolate a, sign lookup table? X square? I think it must be X square. But it depends actually where the value goes. Right. So where the value goes. If the value rises, you want to actually curve to go like that. And if it goes down, well, yeah, this depends on the direction. So linear is the best way of interpolation, is the easiest way of interpolation, right? So, but it would be better to have like a smoother one. So quadratic one... Okay. So alrighty. So we sped up everything a little bit, but let's go back to the thingy. Right, let's go back to the thingy. And this time I'm going to enable optimizations and see if it's gonna go a little bit faster. Okay. That feels a little bit faster, a little bit smoother, I would say. Oh, there is another interesting thing is that we're losing a little bit of a precision because I'm chopping off microseconds and nanoseconds. One of the things I could do actually, I could only chop nanoseconds, right, and don't chop the microseconds. So maybe that will make it slightly smoother. So you now have more information. This is all CPU, by the way. Yes, this is all CPU completely. It's hard to tell if it's better or not, but and on top of that, we also I also develop on the same machine as I stream. So there's a lot of you know, interference from the OBS, right? So without me streaming, I think it's going to be way faster, and it would be rather interesting to actually like go ahead and extend our profiler so the profiler can measure the performance while it's rendering the entire thing, averaging out the each individual face and then like display the current thing in real time. That would be kind of cool to see that, but unfortunately we already spent 2.5 hours just messing with X11 and I'm already extremely tired, so I think we're gonna do that next time. Right, so I achieved what I wanted to achieve. I wanted to hook up our renderer into the X11, right? So, and yeah, it works and it even animates in more or less a real time. It could be way faster, but the fact that it's all done on CPU is freaking amazing, not gonna lie. I really like the fact that this is like it's feasible on CPU. It is in fact feasible on CPU, and you could probably make a whole game without OpenGL, like a whole 2D game without any OpenGL, right? So, and if you're only learning programming, like game programming, and you don't want to like spend too much time on these APIs and stuff like that, but you still want to have like total control over everything, I guess this could be a feasible way of doing that. I think, if I remember correctly, the handmade here was supposed to be written like that initially, right? So the initial idea of handmade here was actually like render like that and don't worry about these graphics APIs and stuff like that. Right, so this is a really fun way of programming, you know, things. It is a really fun way because you just set up your back buffer with pixels and there you go. You can forget about all of the platform stuff and just render everything into that back buffer and you have all control over the things. So that is extremely cool. I really like that. I really, really like that. So yeah, it will be kind of cool to try to speed it up, but I'm already super tired, so I'm gonna leave speeding this thing up and making it cooler and stuff like that for the next time. I hope today's stream was interesting and educational, but unfortunately, boys and girls, it is time for me to go. It is time for me to go. Thanks everyone who's watching right now. I really appreciate it. Have a good one and I see you next time. I don't know where, I don't know when. Check out the description, the links in the description if you're watching it on YouTube, right? So this entire thing is going to be on YouTube and you're watching it if you're watching it on Twitch. Subscribe to this channel where I upload all of the recordings of my streams. You can also check out the source code of this thing. I'm gonna clean up this code a little bit and post it on GitHub a little bit later for everyone to play with, right? So this is not the thing yet. Here is the thing, right? And yeah, I gotta go. Thanks everyone. I love you all.